Okay, for the trigonometry, most important thing, let me underline here, the definition of sine of x, cosine of x, tangent of x, and cotangent of x. So sine means opposite over hypotenuse. First of all, to use the trigonometric ratios, we should have a right triangle. This is the first case, right triangle. What is right triangle? A triangle whose one of the side is 90 degrees. And this notation, let's say this notation, or some books use this, it means that it's a 90 degrees. Okay, so this is 90 degrees. Whenever you have 90 degrees, you can use the trigonometric ratios. So what is the sine of x? Let me make it bigger. So sine of x means opposite over hypotenuse. We should memorize this. Opposite of the angle, which we have side length 5, and hypotenuse, which is 13. You know the hypotenuse means? Hypotenuse is the largest side of a right triangle, and hypotenuse is a side that opposite of the 90 degrees. So always opposite of the 90 degrees, it's called the hypotenuse. Okay, and then cosine means adjacent over hypotenuse. So what is the adjacent side of x? X has two adjacent sides, this and this, but we know that this is the hypotenuse, so we have to use this one. So it is 12 over 13. Tangent means opposite over adjacent. So opposite of x is 5, adjacent is 12. And cotangent is adjacent over opposite, which means cotangent will be 12 over 5. Now, let's go. And we already discussed before the spatial triangles. It's very important. So whenever we have 90, 30, so this is directly 60 degrees. If we call the hypotenuse as 2 units, 30 degrees is half of the hypotenuse, and 60 degrees is half of the hypotenuse times root 3. I mean, even you can say like this, 2x, x root 3, where this is 30 degrees, this is 60 degrees, and this is 90 degrees. But this is better, 1 to root 3 directly. Now, when I look at here, for example, for this triangle, what will be sine of 30 degrees? Sine of 30 degrees as a default, I think it's better to memorize it's 1 over 2. But by looking this figure, we can directly say sine of 30 opposite, which is 2, over hypotenuse, which is 4. 2 over 4, which is 1 over 2. What about tangent of 30 degrees? So when you know this triangle, tangent 30 is opposite, which is 2, divided by adjacent, which is 2 root 3. When you simplify, 1 over root 3. Even this triangle, look, tangent 30, same, opposite 1, and adjacent root 3. So trigonometric ratios are everywhere same. I mean, even in this triangle, it is same. It's not changing. Sine 30 is sine 30, cosine 30, cosine 30, everywhere. And one more important thing, let me tell you. Sine of x, as a result, could be maximum 1 and minimum -1. So you don't have sine of x, for example, 2.5. If you have, this is wrong. There is no angle whose sine is 2.5. Okay? So the maximum sine of x is 1, minimum is -1. Similarly, cosine of x, the maximum is 1 and minimum is -1. And something in your mind, x-axis we regard as cosine axis, y-axis we regard as sine axis, okay, to make easy calculations. Now let's go down. And it says that to memorize there is sohkato, something like that. I mean, you may use to memorize this, but I'm not using anymore, so you can use if you wish. There is something very important, very important. Let me explain this maybe in the whiteboard. So in trigonometry, Functions are called functions, and their whiteboard, pardon. Share whiteboard. Where is the whiteboard? What happened? Sometimes I'm confused. Yeah, I have to use this one, right? Functions and cofunctions. What does it mean? If you have function sine of x, we have to know that its cofunction is cosine of x. Definition. If you have cosine of x, its cofunction is sine of x. If you have, oh my God, I click again the same thing. 1 minute. So if you have tangent of x, its cofunction is cotangent of x, tangent of x, and so on. Second, cosecant, cosecant, secant. Why this is important? We have one rule. Rule says this. Sine of 90 degrees minus x is equal to its cofunction, which is cosine of x. Similarly, cosine of 90 degrees minus x, sine of x, tangent 90 degrees minus x, cotangent x, and cotangent 90 degrees minus x is tangent x. I mean, sine of 20 degrees is equal to cosine of 90 degrees minus 20 degrees, which means cosine of 70 degrees. So sine of 20 as a result, exactly cosine of 70. These are the same things. So sine of 45 is cosine of 90 minus 45, which is 45 degrees. Or sine of 30 degrees, cosine of 90 minus 30, which is cosine of 60 degrees. Is this clear? Do you have any question? Any question? No question.
Sir, we have to memorize all of this, right?
But this is only one thing,
Okay.
Ahmed. So sine, cosine, cosine, sine. These are cofunctions. Tangent, cotangent, cotangent, tangent, cofunction. And we have only one rule. 90 minus x, its cofunction. I mean, sine of 90 minus x, its cofunctions x. That's it. These are same.
Come on.
Only one rule, you may think. So let's go back on the book. Pardon. What's going on? Yeah. And another important thing, guys, we have XY coordinate plane, and this XY coordinate plane has namely 4 different quadrants. First quadrant, or shortly Q1, we may say, Q2, Q3,
Sir, you're not
and
sharing
Q4.
screen, sir. You're not sharing.
You are not seeing. Thank you. Thank you. You see now?
Yes, sir.
Okay. So whenever we have XY coordinate system from 0 to 90 degrees, it's called first quadrant. 90 to 180 called second quadrant. Here third, and here fourth quadrant, it is called. And here in this quadrant, let me draw it one more time. We have some important things. So we have, you know, sine, cosine, tangent, cotangent, this stuff. Now, I will say there is one abbreviation, ASTC, or all students take calculus. What does it mean? All means in the first quadrant, all of them are positive. Sine is positive, cosine is positive, tangent is positive, cotangent is positive, secant is positive, cosecant is positive. In the second, students for S, for sine, only sine is positive, which is here, but cosine is negative. So tangent is sine over cosine, cotangent is cosine over sine. That means only sine is positive, all the others negative. And here, all the students take. So here the tangent is positive. But if tangent is positive, automatically cotangent is also positive. Instead of memorizing this, I really do not prefer this. I do not prefer this. Just use this information. It's, I think, so simple. Let me draw XY coordinate system. Very simple. X, Y. Guys, first of all, can I say that, oops, I'm clicking the other side always. Let me maximize this. Okay, no problem there. Can I say right now, X values are in the first quadrant, positive, 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 positive. Even in the fourth quadrant, positive, 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 positive. And Y values in the first quadrant, positive, 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 positive. Even in the second quadrant, positive, positive, positive. Now, X values in the second quadrant, negative, 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 negative. In the third quadrant, negative, 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 negative. Y values in the third quadrant, negative, 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 negative. Even fourth quadrant, negative, 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 negative. Is this okay? Where is positive, where is negative? I mean, when you take any number here, X is positive, Y is positive. When you take any number, X is negative, Y is positive. When you take any number, X is negative, Y is negative. When you take any number here, X is positive, Y is negative. Any question till here?
No, sir.
No. And now, think this. X-axis is cosine. Y-axis is sine. What does it mean? If you take any angle here, for example, 45 degrees, 30 degrees, whatever, in the first quadrant, here, X is positive, X means cosine. So cosine is positive, sine is positive. If you take any angle here, like 130 degrees, for example, its cosine is negative, its sine is positive. If you take any angle in the third quadrant, so its cosine is negative, its sine is negative. If you take an angle like 330, let's say, in the first quadrant, cosine is positive, sine is negative. Is this okay for you?
Yes.
And then what about tangent? A tangent means sine over cosine. So you can say that for this angle, one positive, one negative, direct the negative. Here, negative and negative, positive. Here, positive and negative, negative. So no need to memorize, but you should know only this. X is cosine, Y is sine, and the things positive, positive, negative, negative. And then it's easy. Okay, so now let's go back to this. We already mentioned this. Spatial triangle already mentioned this. Now, and by the way, in this book, my dear students, it is wrong. You can correct, I mean, when you study by yourself, this is wrong. So let me solve the right one. Question is sine of 330. Be careful now. First of all, what am I going to do? I directly draw XY coordinate system directly. And 330, where is it? You know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and also 360 degrees, same position. When you have a unit circle, okay, 0, 1, 2, 3, 4, 5, till here. And then, where is 330? Isn't it here? This is now 330. Yes or no, tell me.
Yes.
So, what is the acute angle? Reference angle, we call actually. Reference angle, which means the terminal side with the x-axis. I mean, is this angle 30 degrees, can we say? Yes, no?
Yes.
Yes. So sine of 330, my dear students, it's equal to sine of its reference angle. Reference angle is the angle in the first quadrant. I mean, between 0 and 90 degrees. So you have 330. How can you find reference angle? So this is now 30 degrees. Now,
How did you know it's 30 degrees?
this is totally 360, isn't it? Round angle, 360.
So how do you know this angle is 30? Not 30.
But given, one more time. Okay, let me explain one more time. One more time.
Okay.
One more time. So XY coordinate system I am drawing. Now, 0 degrees, 1, 2, 3, 4, 90, 91, 92, 93, 80, 180, 181, 182, 183, 270, 271, 272, till here now, this is 330. Is this okay? Firstly.
Yes.
So if this is 330, you know that round angle is 360. So if I continue now, I will come starting point. I start here as a 0, 1, 2, 3. Now I am coming same position. I will start here. You are coming to same position. If till here 330, what will be this part? Since totally 360, 360 minus 330 will be 30, isn't it?
Yes.
Okay. So the thing is this right now, guys. Sine of 330 degrees almost is equal to sine of 30 degrees. Only one thing I have to consider. Sine. Positive or negative. Your original question, which is 330, in the fourth quadrant. In the fourth quadrant, sine, which is y-axis, positive or negative?
Negative.
Negative. Put it negative here. So result is negative sine of 30. What is sine of 30? Opposite adjacent, which is 1/2. Finished. I can give you a general rule in the whiteboard, but let's go a little bit solving the questions. So sine of 330 we have calculated. What about cosine 135? Okay, let me explain here. Cosine 135, what will be? Question is cosine 135. And then I can give you general rule. Now without rule I am solving. I will give you general rule also. First of all, where is this angle? In which quadrant? Pardon. Stop, share, whiteboard, maximize. Okay. So where is this angle? Isn't it here somewhere? This is now 135 degrees. Yes or no? Yes or no?
Yes, sir. Yes. Yes.
Okay. So my question, cosine of 135 is equal cosine of what between 0 and 90 degrees? How can I write this? The answer, just look at the figure. Tell me this. What is this angle? How can you calculate this angle? Is it 180 minus 135?
Yes.
What do you think?
Yes,
So
sir.
which is 45?
Yes.
So now the cosine of 135, which is my question, it's equal to cosine of 45. Only one thing, positive or negative. So since 135 original question is in the second quadrant, cosine is negative. So just put it here negative. And then cosine 45, if you memorize it before, it is √2/2. If not, you have to know this spatial triangle, 90 degrees, 45 degrees, 45 degrees, 1, 1, √2. So cosine means adjacent over hypotenuse, so 1/√2. 1/√2 means if you multiply numerator and denominator by √2, 1 times √2 over √2 times √2, so it will be √2/2, which is here. That's it. We solved the question. Look at one more time. If it's something is strange, not clear, ask me. And also, I will show you something else. One way I will show you. Chat box. No, in normal SAT, you will see this. SAT 1. I mean, not subject, that's normal SAT.
So we'll see this lesson in SAT 1, right?
Yeah. In normal SAT, you can see question. Now, I want to explain something, my dears, a little bit, maybe advanced level, a little bit, not so much. Rule. When you use 180 degrees or 360 degrees, use original function, but keep in your mind where is your question, which means angle. Where is your angle? What does it mean? Cosine of 135 degrees, dear students. My aim is to express the question an angle between 0 and 90 degrees. So I will modify this. I will do something and result will be an angle between 0 and 90. So cosine of 135 is equal to cosine of 180 minus 45 degrees. Is this correct? Check it. Yes, no?
Yes.
And then since I use 180 or 360, I am using the original function, which is cosine is still cosine, okay? And forget about this right now. Here, what did you use? Just this acute angle, put it your result. And the last part, keep in your mind that where is your original angle? So original angle 135, which is here. Here cosine is negative, so put it negative. So result is negative √2 over 2. It's actually similar to what we done before, but this is as a rule. Example, cosine of 330. It was our question. So cosine of 330, my dear, is equal to cosine of 360 minus 30. So since I use 360, the function is cosine. And forget about this, put it just 30. Only thing, positive or negative, draw. So 330 is in the fourth quadrant. In the fourth quadrant, this cosine is positive. So this is positive cosine. If this is cosine, I mean, the result is cosine 30, which is √3 over 2. If the question is sine of 330, answer is sine of 30, but sine is negative. So negative sine 30, which is negative 1 over 2. It was our question. So this one, let me screenshot and I will send in Google Classroom to you. Now the second rule, actually similar to this. When you use 90 degrees or 270 degrees, use cofunction and keep in your mind where was original question as a quadrant to decide plus or minus. What does it mean? If I ask sine of 135 degrees, my dear students, this is equal to sine of, be careful now, tell me, if I say 90, if I say, I can use even 180. If I say this is 90 plus 45. Now, 90 plus 45, is it 135? Yes. Yes or no? Yes or no?
Yes. 132.
So when I use 90 or 270, use cofunction. What is the cofunction of sine? Tell me. What is the cofunction of sine?
Cosine.
Cosine, right?
Yeah.
And forget about this directly, cosine 45. Keep in your mind, original function, where was it? Sine 135, second quadrant. Second quadrant, sine is positive, so this is positive cosine 45. So result is √2/2. Finish.
Mr. I have a question.
Yes, ask me, but I want to use also second way by using 180. But ask your question.
Okay, so we choose whether to choose 90 degrees or 180 or 360.
It depends on you. Totally it depends on you, which is suitable for you. Okay? So sine of 135. Question. So sine of 180 minus 145. I can say also. Is it correct? Yes, no? 180 minus 45. Is it this?
Yes.
30. So since I use 180, it is now same function, not cofunction, same sine of 45. Only I should keep it in my mind, sine of 135 second quadrant, so positive. So positive sine of 45. What is sine of 45? √2/2, I know. So these two answers are same.
Okay, Mr. I have a question. So we can subtract 270. I mean, we can add 270 plus 45.
Here, you can use 90 or 180, but you can't use 270. Why? 270, if this is your question, 270 minus 135, it's not element of 0,90. I mean, when you use this subtraction, you are aimed to get an angle which is in the first quadrant. Is it okay, what I mean?
Yes, sir.
Tamam. So if no question, let me go back to Panda book again. So let us solve some questions. Tangent 210, for example. Let me explain here one more time. Tangent of 210, isn't it equal to 180 plus 30? What do you think? Yes, no? Yes, no?
Yes.
So if I use the 180, I should use same function. So this is equal tangent 30. Only the thing, where is it? Positive or negative? 210 somewhere here. So sine means, tangent means sine over cosine. Cosine is negative, sine is negative. Negative over negative, it's positive. So result is positive tangent 30. And then what is tangent 30? I don't know. So let me draw spatial triangle. 2, 1, √3. So this is 60, this is 30. So tangent 30 means opposite over adjacent. Pardon. Tangent 30 means, yeah, opposite over adjacent. Adjacent is this one, not this. So result is 1 over √30. If this is in the alternative, do it. If not, multiply by √3. So it will be √3 over √9. So it will be √3 over 3, which is here.
Okay, Mr. I have a question. So I have a question.
Yes, sure.
Can we say 270 minus 60?
270 minus 60, bravo, you can say, let's say it. So this is equal to now 210.
Now we use
So now this is equal to, let me continue. 270 minus 60 is 210, excellent, that's correct. Since you use the 270, you have to use cofunction. So it will be cotangent of 60. It's okay? Now, positive or negative, same thing. Tangent of 210, it's positive. So result is cotangent 60. What is cotangent 60? Cotangent means adjacent over, tell me, opposite. So 1 over √3. You see, it's same. 1 over √3, which is √3 over 3. You are free to use which one is easy for you. Tamam? It is totally depending on you. You decide.
So yeah, Mr. Even if we said 360 minus, I don't know what. 70
But 210, you can't use 360. To get 210, It must be 150, but 150, it's not acute angle. To get this, no, we can't say.
Okay.
Tamam. Our aim, but one more time, when you have any angle, we should have reference angle. What is reference angle? This terminal side and x-axis. So this is always acute between 0 and 90. If angle is here, so again, this one with the x-axis. So this is always acute between 0 and 90. Or if this is your angle, references between x-axis and the terminal side. So it is here always between 0 and 90. Okay?
Okay, sir.
Yeah. Okay, good. And then no need to memorize. I always draw a circle. It depends on you. So this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. This is 360 degrees. If this is a unit circle, which means 1, 1, 1, the radius is 1 and center is at 0, 0. Can you tell me what is the coordinate of this? Isn't it 1, 0? X is 1, y is 0 here. Here, x is 0, y is 1. Here, x is -1, y is 0. Here, x is 0, y is -1. Is this clear for all of you? The coordinate of this 1, 0, 0, 1, -1, 0, 0, -1. Yes or no? Tell me. Is
Yes.
this okay? Now, my question, what is sine of 0? Just look at, where is 0 degree here? So the coordinate, what is that? 1, 0. First one is always cosine, second one is always sine. What does it mean? Sine of 0 is 0. What is cosine of 0? Where is the coordinate of 0 here? 1, 0. Cosine is first component, which is 1. Finished. What is sine of 270? 270. So 270, where is it here? The coordinate is first is cosine, second is sine. So 270 is -1. Finished. Okay? Understand the logic here? Instead of memorizing this table.
Can you give one more example?
Tell me sine of 180. What's that? So 180, it's here. The coordinate is x is -1, y is 0. Sine means the second component. So sine of 180 is 0. What about cosine 180, which is cosine pi? -1.
Okay.
Tamam. Tangent, cotangent, you can calculate by yourself. Tangent means sine over cosine. Cotangent means cosine over sine. Oh, finally. Let's solve question. Now, at the beginning of the lesson, do you remember I told you that sine of 90 over this cosine of x?
Yeah.
So can you tell me cosine of 40? Isn't it equal to sine of 90 minus 40? Think a bit.
Yes, it is.
What is 90 minus 40? 50. What is this? This is my question. My question is find sine 50. This is the question. So sine 50 is directly cosine 40. They are equal. A cosine 40 is A, so the answer is A. That's it. Check it one more time.
Mister, don't they want 50 or they want A?
Let me clean and do it again. Let me clean and do it again. Now, I am solving again. The question is find sine of 50. So I am writing sine of 50 is equal to cosine of 40. Do we agree for this or not?
Yes.
Do you know what is the rule?
Yeah, pi over 2 minus.
If sum of two angles is 90 degrees, their sine and their, how can I say, trigonometric functions and cofunctions are equal to each other. I mean, sine of alpha is cosine of beta, something like that, 40, 50, this case. So sine 50 equals cosine 40. For example, what is sine 72? Can you tell me? It is cosine of 18. What is sine of 89 degrees? It is cosine of 1. Okay? What is sine of 90 degrees? It is cosine of 0. Let me prove. Let's prove. 90 degrees, where is it here? What is the coordinate? X is 0, y is 1. So sine of 90 is 1. Cosine of 0, where is 0? Here. Where is the coordinate? 1, 0. Cosine is first, so 1. 1 is equal 1, finished. Okay? So let's turn back our question. Cosine of A given as A. This is my question. So directly, my question is equal to A. Finished. Tamam? Yes or no? Okay, let me write one question in my mind. If sine of 70 degrees is X, what is cosine of 20 degrees? This is the question. What is the answer?
Is it 10?
Sine of 70 is equal to cosine of 20. So cosine of 20 is X. The answer is X. Finished.
Okay.
Okay or not?
Okay.
Okay, let's go back down, I mean. Okay, yeah, good question. In a right triangle, don't wait, directly draw a right triangle. This is the best way to solve the questions. In a right triangle, one angle is X. You are free. I always prefer this, but you may prefer this, no problem. Such that tangent of X 0.75. What does 0.75 mean? 75 over 100, right? Yes, no?
Yes.
Even I can simplify. So it will be 3 over 4. What do you think?
Yeah, 3 over 4.
So what is tangent means? Opposite, adjacent. So opposite is 3, adjacent is 4. Till here, any question?
No.
If this is 3, if this is 4, and if 90 degrees, I am 100% sure that this is 5. Is this clear?
Yes.
What is the question? Find cosine of X. A definition of cosine, adjacent over hypotenuse. What is adjacent of X? 4. Hypotenuse, 5. This is the answer. Finished. Tamam?
Okay.
Going down. I like this question time. Tell me quickly. Sine of 90 minus theta. What is that? Cosine of what? Tell me.
Of theta?
Yes, that's it. Cosine of 90 minus theta. What is that?
Sine of theta.
Bravo. Sine of theta plus sine of theta, 2 sine of theta. Cosine of theta plus cosine of theta, 2 cosine of theta. 2 common parentheses, sine theta plus cosine theta. So the answer is D. Is it okay?
Yes.
No. Let's talk about this question. Whenever you have right triangle, when you read this sentence, don't wait, draw. ABC, say it ABC, how you want, ABC or ABC, no problem. It's problem now. Why? It says C is 90. It's okay, we are right, C is 90 here, very good. AB is 30, so this is 30. What does it mean? Hypotenuse is 30. Cosine of angle A, so this is right, angle A, 5 over 6. Oh my God, look at now. Cosine of A, isn't it this, if I call this as X, cosine of A is X over 30 by using this figure. Is it correct? Yes, no?
Yes.
Yeah.
So in the question, cosine of A given, 5 over 6. So cross product, when you do cross product, X times 6,
So
5 times 30. So simplify, X is 25. That's it. Or even you can use logic. From 6 to 30, 5 times. From 5 to X, 5 times, directly 25. Okay?
Okay.
Now, this is also famous question type. It's simple also, not difficult. Tangent X is M. Draw, don't wait. Draw right triangle. Put somewhere M. Tangent means not M. Angle is X, right? So Angle is X. Tangent means opposite over adjacent. This is M. So I can say that M over 1. Why? Opposite M, adjacent 1, M over 1 is M. Any question?
No.
Now, Pythagorean theorem, isn't it this is 1 plus M squared? Yes, no?
Yes, it is.
And then question, sine of X. What is sine of X? Opposite over hypotenuse. So M over 1 plus M squared. Finished. Oh, sorry, not this. Not this. M over M squared plus 1, C here. M over M squared plus 1. We solved the question.